How's it going? My name is Aaron, and in this video I'm going to show you how to run your Govee permanent install lights with WLED controller. And so if you've seen my videos, you know that I like to use these Apache 1800 boxes you get from Harbor Freight. Super cheap, very weather resistant, so we're going to jump right into it. Here I put some blue tape on the box here. I made 3 markings. One's going to be for my input of my power, and the other one's going to be for the output of everything. And then the middle, we're going to go ahead and we're going to add a fan just to get some of that heat out of there. I'm using a step bit here to get that hole made. It's a 2 inch and 3/8 step bit that we use on there. The other holes were a 1/2 inch a piece. Now I'm getting some PG7 strain reliefs that I use. I get those from wiredwatts.com. You get a pack of 10 for pretty cheap on there. I also got this fan off of Amazon. The tricky thing with the fan is trying to get it lined up so the exhaust is perfectly centered in that hole there. So when I do make these pilot holes, I do the pilot holes from the inside to the outside, and then ream them out a little bit on the outside so the fan has a little bit of wiggle room so I can get it to play and get it to line up correctly in there. I usually have the exhaust port pointing up just so it can exhaust some of that cold air coming in, and then I'll make holes in the box at some point, depending on where I install it, to exhaust some of that heat that's coming out of there. The screws I'm using are a 632. They're about 1.5 inches long, so it goes through the outside. Gives me a little bit of threads on the other side to get a fastener on the other end. These cables I got from BTE Lighting off of Amazon. It's a 3-pin IP65, so they're waterproof. They're the 15 millimeter size, and I've got a male and a female here. And I wanted to make sure that the cable was different than the other cables that I use for my lighting displays. I didn't want a Raywu connector on there or an X connector on there. I didn't want to mistake anything in there. So these are actually smaller, but they're the same gauge as my Govee lights. So here I am. I'm putting the male connector through the cable strain relief there. So I've got my male on the right, my female on the left. And here's my tails on the end here. See that I got them all spread out, ready for the next step. So I've got this board that I've printed off of my 3D printer, so I can get both boards on there and get them fastened on there at the same time. Just makes it a lot neater. You can use any kind of plastic board, anything that's non-conductive. I'm using these M3 screws and fasteners that I got off of Amazon. The link is down below. And I'm going to attach it to this board, but I'm going to make them as a standoff. So I'll put the screw in first, I'll add a fastener, then I'm going to go ahead and attach my components, which is going to be my ESP32 board with a breakout panel that it sits on. And the other one is a buck converter that's going to actually change the voltage from the 36 volts that's coming in, and it's going to change it down to the 3.6 volts that the ESP requires. So you can see here's my first screw that I'm putting in. I've got all of my 8 screws now. I'm going to go ahead and mount my boards on here and get those fastened down. Now that I've got those fastened down, you can kind of see that there's a gap between the board and the piece of plastic, and that just helps so there's no connectivity between anything, and so it kind of isolates everything off of that board there. So anything I put that board on, I don't have to worry about it shorting out or touching anything it's not supposed to. So I have some leftover wire from another project. I'm just going to go ahead and use that. It's 16 gauge wire. I'm going to cut off a couple pieces here. That's going to be my positive and my negative that I'm going to use to go into the buck converter. And I'm going to use that same cable to go out of the buck converter to power everything. And before we get started, let me actually show you how these buck converters work. So this converter here, your input's on the right and your output's on the left. It can take up to 36 volts as an input, and it can attenuate it all the way down to 1 volt. And so here I'm using a 12 volt power supply. And I suggest doing this before you install it or put it anywhere. Go ahead and get it all adjusted so that when you power up, you don't forget to do this. So I'm going to go ahead and plug in this 12 volt power supply. I've got it into the inputs, and I'm going to show you here that it is clearly getting 12 volts in. I'm going to go ahead and push this button and show you the input. So here's my input side. It's 12.2 volts in. I hit that button and I've adjusted it to be 3.6 volts out. Now how you adjust it, there's a little screw at the very top. It's a little set screw, and then you can turn it to the left or turn it to the right, and that's going to adjust your voltage. As you can see, as I'm turning it to the right, the output voltage is changing and going higher. So I can take that all the way up to 5 volts or 12 volts or whatever you need. And as I turn it to the left, it actually gets lower, and that's where I turn it to the 3.7 or 3.6 volts that is required of the ESP32 that I'm using. So here I've got the input connected, and I'm going to connect the output now. I'm using the brown wire as my positive. It's going to go in what's called the VIN, the VIN of the ESP breakout board. That's my input there. And there's my ground that I'm going to connect. And this is the output of that buck converter. So the output is outputting 3.7 volts, which is required by that ESP32. Once when I've got that plugged in, you can see that I've got it all screwed in and terminal down. So my input's on the top there, ready to come in from the 36 volts or 12 volts, whatever you want to decide. But in my case, this is going to be 36 volts input coming in. Now let's go ahead and throw it in the box here, and we're going to start getting everything wired up. Again, on my right-hand side is my power coming in, and my left-hand side, that's the output going to the light. So let's grab some Wagos or Wagos, however you say it in your part of the country there. I call it a Wago. We're going to go ahead and Wago these power together. Now the reason we're going to do the power together is because the lights require 36 volts or whatever your lights are going to require. So I have to jump the power coming in so that that 36 volts continues onto the lights. Remember, we only want to interrupt the signal that is going to them. So I've jumped the power together. I've also jumped the ground together. And so once again, all we're going to do is we're going to provide our own signal going to the lights to control them. Right here, I'm going to tie in the power of the converter. It's going to tie into this first one here. There's my ground I just put in. And now I'm going to go ahead and put in the hot. So now I've got 36 volts going to my buck converter, which is going to convert it down to 3.7 volts. 3.7 volts is going to be outputted to the ESP32. So now we're going to go ahead and take the controller side from Govee. We're going to go ahead and chop the end of it off here. The reason why we're chopping the ends off is because they don't make adapters, and you can't buy the end because it's a proprietary connector. And so we're going to go ahead and chop off the end, put the end on that we want, and then we'll be able to control it with our WLED. So here I am chopping off. This is the side that goes from the power supply to that controller. So when I cut it off here, you can see that there's only 2 lines on there. There's a positive and a negative, so that's just power coming in. I like to tin the ends before I solder anything or put it all together. And so there's our positive or negative. I'm going to take those same cables that I used earlier, and we're going to go ahead and solder the positive to the positive, the negative to the negative. We're going to go ahead and cut off this yellow cable. That's our signal cable. We're obviously not using that. And we're going to just solder these 2 ends together here. So we have a male end on the right hand and the female end on the left end. I'm going to go ahead and get some heat shrink now. I'm going to put a big piece of heat shrink and two smaller pieces of heat shrink on the cable side of it, and get little pieces of heat shrink in there as well, to cover all of my solder connections, and then to try to watertight as much as I can on this cable. Just makes it look a lot better, makes it look prettier. Okay, now it's time to do the other side of the controller. Up here you can see that there's three wires. There's a red, a black, and a white. The red is your positive, the black is your negative, and the white is the signal going to the lights. And so if you're wondering why we don't Wago these, um, the signal does not like the Wagos. It does not pass well. You're going to have issues. You can try it. I've tried it. It doesn't work very well. So I just go ahead and solder it since it's going to make a permanent connection anyway. So same thing. I load up my heat shrink on my cables here. I heat shrink the tiny connections. I'm going to go ahead and heat shrink the cable. And now we have a way to get in and out of our controller with the Govee power supply into the Govee lights. We're going to go ahead and take our signal output now and put it into the ESP32 output. I put it into the D2 slot. That's what I have programmed on my WLED, is that the output for the Govee lights is going to be on GPIO2, which is that D2 slot there. Went ahead and connected that, so now it's driving there. So we just double check all our connections. Our input power is coming through the top, gets converted to 3.7 volts, powers up our ESP32. ESP32 spits out new data and is going to go down that line and going to tell our lights what to do. Here is the moment of truth. We're going to go ahead and hook up the power supply to make sure this is all good. You can see that it's a little hard to tell, but it's 36.7 volts coming in, and I push the button to see what the output is, and it's actually 3.67. So 3.67 on the output, 36.6 on the input. Hook up our lights, and by default they should propagate to the color orange or red. And so here they are. It looks like they're working. Let's go ahead and pull out the WLED app. We'll show you that the app is controlling the lights. Go ahead and click on here. And you see, here we go. I'm going to drag my colors around. We've got no flashing. We've got the reds, the blues, the greens. Everything's lining up the way it's supposed to go. So that's how you control your Govee lights to WLED with the app there. Pretty simple. You just have to be brave enough to cut your cables up and strip them and make things happen. The one last thing I forgot to include, I've got to power up our little 5-volt fan. And so our 5-volt fan is going to work just fine off of the 3.7 volts that's coming in from the converter. I went ahead and just propagated it right to the input of the buck converter coming out to the input, and I went ahead and put the ground on the other side because there's another ground. There's a separate ground on the other side there. So there we go. I hope you found this video informative, and thanks so much for watching. If you guys have any questions, just throw them in the comments below. I'll see if I can help you out. Check out my other videos, and once again, thanks for watching, and we'll see you on the next one.